These notes cover section 9.3. In this case, we're going to be multiplying polynomials together and noticing that there are some special patterns that we observe about these products. It'll be important to recognize these special products when we start factoring, that is, trying to do the process of multiplying polynomials together in reverse. The first pattern we're going to look at is called the square of a binomial. We take a binomial, that's an expression that has two terms, in this case a and b, and we take that whole expression and we square it. If we were to write this squaring out the long way, we see that we would have a plus b times a plus b. If we were to draw this out using an area model, we would have a square that is a plus b units along one side and a plus b units along the other. If you look at the squares inside this area model, you'll see that in blue, there's a square whose area is a squared. In yellow, there's a square whose area is b squared. And there are two rectangles that each have an area of AB, a times b. If we add all four of these squares together, we have a squared, the blue one, plus 2 ABs, that's the two green rectangles, plus b squared. This pattern, a squared plus 2ab plus b squared, is the result when you square a binomial. Here's an example of what this pattern might look like if we replace a and b with some numbers and variables. Let's take the example x plus 3 squared. In this case, the a in our pattern is the variable x, and the b in our pattern is the constant 3. So when we multiply x plus 3 times x plus 3, what we get is x squared, that's the first part squared, plus 2 times x times 3, that's 2 times the a in our pattern times the b in our pattern, plus 3 squared, that's the b in our pattern squared. In the middle term, we have 2 times 3, which simplifies to 6. So the result is x squared plus 6x plus 9. We can show an area model for this if we show a square that is x plus 3 on one side and x plus 3 on the other side. When we draw in the resulting multiplication, we see that we have a square that is x by x, so its area is x squared. We have a square that is 3 by x, so its area is 3x. We have another rectangle whose area is 3 times x, or 3x. And we have a 3 by 3 square. 3 times 3 is 9. So when you add together the area of these four pieces, we have x squared plus 3x plus another 3x plus 9. Those two 3x's added together give us the 6x that you see above. A second special pattern is when we take a binomial where we have a subtraction problem in it. So a minus b squared. If we were to write this out the long way, we would see that it is a minus b times a minus b. We can show this again using an area model. Across the top we have a and negative b, and down the side we have a and negative b. So that's a minus b across the top and a minus b down the side. We have the blue square that has an area of a squared. We have the yellow square that has an area of b squared. Notice that it's positive b squared because negative b times negative b is positive b squared. And then the two green rectangles each have an area of negative a times b, because in both cases we're taking positive a and multiplying it by negative b. So the result is negative a times b. When we add these squares and rectangles together, the total area that we have is given by this expression. A squared, that's the one in blue, plus negative 2 ABs. Right? We have a negative AB in green, and we have two of them. That's where that 2 comes from, plus b squared. We might also write that as a squared minus 2ab plus b squared. Let's take a look at this with an example that has some variables and some constants in place of the a and the b in this pattern. So an example might be x minus 3 squared. If we multiply that out using our pattern, in this pattern, a goes with the variable x and b goes with the constant 3. So when we replace a and b in our pattern with x and 3, we see that this multiplies out to x squared minus 2 times x times 3 plus 3 squared. When we simplify that middle term, negative 2 times 3 is negative 6. So this gives us x squared minus 6x plus 9. What does the area model look like for this? Well, we have x minus 3 across the top and x minus 3 down the side. So we have the blue square that has an area of x squared, the yellow square down below that has an area of positive 9, again because negative 3 times negative 3 gives you positive 9, and then the two green rectangles, who each have an area represented by negative 3 times x. When you add one negative 3x and another negative 3x together, you get a total of negative 6 x's. The last special pattern we want to look at is when we take a sum and a difference and multiply them together. So in this case, we're taking a minus b, that is the difference between two quantities, and a plus b, the sum of those two quantities, and multiplying them together. What we'll see is that this actually gives us a simpler expression. This is going to multiply out to a squared minus b squared. Let's see how that happens. Here we see a square, and across the top we have a and positive b, and down the side we have a and negative b. So this is a plus b times a minus b. You can see that the blue square in this case is an a by a square, so its area is a squared. The yellow square here is b times negative b, which gives us negative b squared. And in this case, the two green rectangles have the same magnitude. They both have a magnitude of AB, but one of them is positive and one of them is negative. And so when we add all four of these shapes together, the positive AB rectangle and the negative AB rectangle are going to cancel each other out. So if we add all four of these shapes together, the total area of the big square is a squared plus negative b squared, which we can rewrite as a squared minus b squared. Let's take a look at this with some numbers in place of the a and b in our pattern. So we have a plus b times a minus b equals a squared minus b squared. Let's try this, replacing the a in our pattern with x and the b in our pattern with 3. So we have x plus 3 times x minus 3. What I've shown on this line here is what you get when you multiply these out using FOIL. And you'll see that those middle two terms, plus 3x and minus 3x, drop out. So you have x squared minus 9. Now you might say, this doesn't exactly look like the special pattern shown at the top of the screen, because at the top of the screen we have a squared minus b squared, whereas at the bottom we just have x squared minus 9. Another way to write 9 is 3 squared. And it may be helpful to you when you're hunting for this special pattern to rewrite the 9 as 3 squared. Let's take a look at the area model that goes with this special pattern. Across the top we have x plus 3, and down the side we have x minus 3. So we have our blue square with an area of x squared. We have a rectangle that is positive 3x. We have another rectangle that's negative 3x. And we have another rectangle that is negative 9. Sorry, that's going to be a square that's negative 9. When you add all of these together, the positive 3x and the negative 3x cancel each other out. And so you end up with x squared minus 9. Now, I'd like you to practice. Please draw out the boxes and show the product for each of these three products. The first one follows the first pattern I showed you, a plus b squared. The second one follows the second pattern, a minus b squared. And the third follows the third pattern, a plus b times a minus b. We'll go over the drawings and the results that you have next class.